Hey, Palmerettis. Here we go with some science. It is Wednesday, March 31st. We're going to review this science. I know I said is due today by 2 o'clock, 3 o'clock. Get the science turned in when you get it done. What we're going to do is kind of keep it in line with the math and the science and try to have it to me within the next day. Okay? So we're going to walk through this. Some of you haven't finished it, need to turn it in. Some of you had. Just take a picture of it, send it to me. Like I said, I'm trying to make this easy. Every video is going to be on YouTube. Look at Edsby. Look at your email. Email and Edsby will have the same links, the same messages. Cut right to YouTube. Pull out your text. Play it, pause it, read it. I am going to add videos, other video links. There are two good ones out there that I sent to you. Watch those before you do these answers. Also, get on the Quizlets that I've sent. All right? So Tuesday and Thursday are to get work done and get it turned in and to get on your iReady. And then Monday, Wednesday, Friday are when the lessons are coming. So this was Earth's place in space. This is page 109. Page 110. You've got some EQs right here that you can read through. That's what we're going to be tackling. Okay? Page 111, all right? You can pause it, look at it. Some vocabulary words: axis, rotate, orbit, constellations. It says, find the answer to the following question in this lesson. In what ways do we know that Earth moves? Well, the Earth moves. We know that the Earth spins on its axis, that's rotating, and that it moves in a path around the sun. It's orbit. It revolves. Again, watch those videos. Watch those links that I've sent out. Now, as you read through this page here, we did this math together, hours and minutes, and doing our work, reading about this, but knowing about the rotation, the axis, right? Okay? Over here, again, reading about how that rotation causes our night and our day, okay? So it takes 24 hours for the Earth to rotate once. We talked about the seasonal changes. This is was one of your answers. As the Earth is rotating and it's tilted on that axis, that's going to cause our seasonal changes here. So as the Earth, I just said rotates, didn't I? As the Earth revolves around the sun, right? That's going to cause takes a year, 365 days, but that tilt, that slight tilt that we have is when we have our seasonal changes. So as we're tilted away from it, it's winter here in the northern hemisphere, but in the southern hemisphere, it's summer. So that was one of your answers. So when people come here in the northern hemisphere in December, they have winter time. So in Florida, they're going to wear some warmer clothes. Warmer clothes is not, we're not talking, bundled up for this snowy day here, kind of like up in New Jersey, Pennsylvania, Minnesota, etc. All right, so the revolution, the revolving with that tilt, takes a year, and that's going to cause our seasonal changes. All right, so that's the difference between the rotation, day and night, to the revolving. Patterns in the night sky. Again, on April 6th, you're going to be turning in your observations from the night sky. And the way I talk about this is, imagine in the center of the art room is a big ball, right? And around the art room, Miss Edgman puts up a bunch of your artwork. Your parents come in, or we go down and we walk around it. Well, if I see Alexandra's, or I see Zachary's, or I see Micah's on one side, if I see that on one side, as I walk around, right, on the other side, I'm going to see the other artwork. So let's go back to this one here. So the constellations that I see over here, I'm not going to see over here. So what's moving? Yeah, it's the Earth that's moving. Those constellations stay the same. My favorite constellation is Orion, right? We talked about that one. And if you get out there and you see Orion, he's going to disappear here in the next few weeks. And so watch that star. So hopefully that's what you're seeing in your observations of the stars at night. All right. We walk through this one here, right? Day and night are caused by Earth's rotation on its axis. A lot of you are doing one-word answers. Try to rewrite it. Our Earth revolves around the sun once every 365 days. Earth's seasons are caused by Earth's revolutions and the tilt of the axis. During the winter in the northern hemisphere, there are fewer hours of daylight and it is cooler. When it is spring in the northern hemisphere, it is fall in the southern hemisphere. Constellations appear to move across the night sky because of the Earth's rotation. So as the Earth is rotating, and also, I'm going to say it's also revolving, the constellations look like they're moving. Axis, rotate, orbit, seasons, revolve, constellation. Some words that we'll see with rotate are rotation or rotating. Revolve, we'll see words like revolution or revolving. All right, so getting to some of our answers here. You could draw a picture here of the side of the Earth facing the sun should be labeled day, and on the other side it's night. Very simple. Axis should be drawn through the Earth's center. Do it on its tilt. The sun does not move. It's a star. Remember, we talked about that. Okay, a lot of you got to remember that. The sunset occurs because Earth is rotating around its axis. As Earth turns away from the sun appears to set. So again, walk through on that one. Number 4, a lot of us are putting the word the Earth rotates. The reason the constellations are in the night sky and we don't see them during the one part of the year, we only see them at one part of the year. For example, Orion, he's going to disappear in a little while. Well, the reason is because the Earth is revolving around the sun. Many constellations are seasonal because we can only see them when Earth is in a place in the night sky. Down here, the Earth's northern hemisphere is tilted toward the sun for part of the year. As Earth continues its orbit around the sun, the northern hemisphere is tilted away from the sun. This causes our seasonal changes. So make those corrections. You don't have to send them back to me, just make those corrections. And then here we all talked about this, and you guys are doing a good job with this one, saying, hey, when you come here in the northern hemisphere in December, Florida's going to be cooler. Don't say freezing, right? Carter, you said freezing was 32 degrees. Totally correct. It's going to be cooler. We'll need maybe a long sleeves, but we could still wear shorts. It's Christmas time. We're wearing flip-flops and sandals and sliders and stuff like that. I don't wear sandals, so don't laugh at me. All right, where do I want you guys to go today? So you finished page 122. So we're going to pick up at page 123. All right, slide that out of the way. And page 123, I want you to meet these spacemen on Earth, Neil deGrasse Tyson and Michael Kubrick. Read about these guys. That's page 123. Page 124, be an astrophysicist. Just read through this, okay? What are some uses for digital three-dimensional maps? What are some uses for those? Okay? And now this was a lesson we did in class, if you remember, all right? How does Earth move in space? Remember we had, I forget who stood in the center of the room as our sun. And then 2 of you, one was the Earth and one was the moon. And we did that dance, right? So we did that same exact thing. And just read through this one here, all right? And just kind of read through it. Now, as you think about it, what do you think you will learn from this experience? So when we had a student in the center as the sun and we had the Earth and the moon, what did we learn from that? Just write down what you remember. Why do you think you are using different balls as models to represent the sun, the Earth, and the moon? In this one, they use different size balls. Well, one would be really big. That would be the sun. One would be a little smaller. That would be the Earth. And the one would be a little smaller than that, and that would be the moon. So we use the balls, and I'm giving you this answer right now, to just show the different sizes and how they relate to one another. Okay? Why do you think the balls in this investigation are different sizes? The same as we just talked about that. Now, in the space below, make a chart to record what you observed. Draw the sun. You can go back to those pages. Go back to these pages back here. Okay? If you look back here, look back in your text. Draw what you see here. Here's the sun and the Earth, right? You can put a moon around it. Now, here, the sun should be a lot bigger. They didn't do that to scale. So make your sun, show it, the Earth going around it. Now, think about the movements you made during the activity. How do these model the way the Earth moves? How does the Earth move? Well, we just talked about that. The Earth. All right, so you need to give me a couple answers. Tell me about what the Earth does. What movements do they have? That's page 127. And last page for this lesson right here, 128. What movement represented a year? Ooh, go back and look. Explain your reasoning. What took a year to do? How is the movement of the moon similar to that of the Earth? Well, the moon and the Earth both do what? They both do 2 things. Remember our dance, right? It was silly, so explain it. Then write a claim about the rotation of the moon and the Earth. Write a claim about how the rotation of the moon and the Earth compare. So talk about the moon and the Earth. Cite evidence that supports your claim and explain why it supports the claim. So when we looked at the moon, we always see what part of the moon? The face of the moon. Why? And then the Earth, right? So the Earth and the moon are both, all right? Talk about it. Think back on that day when we had the student in the center as the sun, and what did the moon and the Earth do? That dance. Explain that here. Could you use only these 3 balls to model day and night or Earth seasons? Give evidence to support the claim. So think about this one. Could you use only these 3 balls to model the day and the night or Earth seasons? Right? Because what do we need? Well, we need the sun in the center. We need an Earth to go around and to rotate and to revolve. And we need that moon. So could we just do that? So your science right now, work on page 123 to 128. Page 123 to 128 for science. Okay? All right. So as you're finishing those pages, that's for Wednesday, April 1st. I'd like them due April 2nd by 3 o'clock. Gives you Wednesday and Thursday to work on your math and your science. Now, Tuesday, Thursdays, okay? If you go into this ISN notebook, you can go back and any of our EQs or vocabulary that are not defined, go back. Take your EQs and answer them now. You can go back and answer those now. Take your vocabulary. Look in the back of your science textbook and define these. Go online and get the definitions for these and get those written in. And then don't forget, if you get on Myon.com, 1, 2, 3, 4, 5, 6, 7 Myon books right here. That is RP. That is, I think, each 1 point. Okay, no excuses, guys. All right? So on Tuesday, Thursdays, pull out this ISN notebook. Do your definitions for your vocabulary, answer your essential questions, and then read those Myon books. Get your lessons done, get them turned in. Here for you. Miss you guys. We'll talk soon. Bye.